everybody. Today we are going to solve a problem from Fundamentals of Electric Circuits by Alexander and Sedicus 5th edition. The question number is 2.69 and the question is to find out the V naught here. So V naught is the voltage measured across this R2 resistance, and we are having three different cases for this R2. R2 may be 1 kilo ohm, 10 kilo ohm or 100 kilo ohm. And here you have the source with 40 volts voltage supply, and this RS is source resistance of 10 kilo ohm, and this R1 is equal to 20 kilo ohms. So there is no change over these parameters, but this R2 is changing. Here we have the voltmeter model, okay, with the 100 kilo ohm resistance. So without this voltmeter, we'll measure V naught first. In the second case, after connecting this voltmeter, we measure this V naught. Okay, so what is the difference here? In the first cases, by changing this R2 values along with voltmeter model connected and not connected. So you may have this voltmeter or you may not have this voltmeter. For this combined cases, we have to find out. So when you connect this voltmeter model here, what would happen? Only this resistance value across this V naught terminal changes. Here you have actually this. So here we have this R2. So when you connect the voltmeter across this V naught terminals, this 100 kilo ohm is also being connected, right? So this R2 will be in parallel with this 100 kilo ohm that we need to actually calculate. So across which we are going to measure this V naught. But if you don't have the voltmeter, there is no voltmeter, then this V naught is measured across only this R2. That is the case, okay? So we'll solve the problem now. Let's get started. Let's assume that this is 1 kilo ohm. We haven't connected this voltmeter. This is without voltmeter. So how do you calculate V naught? So we are going to use voltage division rule. So we want to measure voltage across this R2. So that can be written as V naught is equal to total voltage or the supply voltage multiplied by resistance of divided by the total resistances that two branches. So that is nothing but this RS plus R1 plus this R2. So this is 40 multiplied by this 1 kilo ohm divided by this 20 plus 10 plus 1. So this is equal to 40 divided by 31. On that case, this V naught is equal to 1.29 volts. So this is for R2 is equal to 1 kilo ohm without voltmeter being connected. So now we move on to this, the same case with the voltmeter is being connected. That means here you have this 1 kilo ohm resistance connected, and across this terminals you have this voltmeter is being connected. So what happens when you want to measure voltage across this terminals? Here the measurement is based on this R2 as well as this 100 kilo ohm. That means this R2 is in parallel with the 100 kilo ohm resistance of this voltmeter. So first we need to find out this parallel combination. So this resistance is the parallel combination of this R2 and this 100 kilo ohm. So it can be taken as 1 by 1 plus 1 by 100 inverse. Okay, that is 100 plus 1 inverse, or we can write it as 100 divided by 101. So that is equal to 0.99 kilo ohm. So these two resistances are now being replaced by a single resistance RT. So now you can measure this V naught. So V naught is equal to the same concept for this. So the total or the supply voltage multiplied by the resistance of that branch across which you want to measure the voltage divided by the total resistances. So it is 20 plus 10 plus this RT. Okay, because this 20 is here, this one, and this is this 10. So it is 40 multiplied by RT value 0.99 divided by it is 30.99. That is equal to 1.277 volts. This is the V naught with voltmeter being connected for the first case, that is R2 is equal to 1 kilo ohm. Now we move on to the second case where R2 is taken as 10 kilo ohm and without voltmeter. Okay, this voltmeter, we assume that this voltmeter is not connected. So this is 10 kilo ohm. So how do you measure this V naught? Simply you can easily calculate. It is 40, because I have already told you the procedure. 40 into This 10 divided by total resistance is 20 plus 10 plus 10. So it is 40 into 10 divided by 40. So it is 10 ohms. So again we consider this case 2 with R2 is equal to 10 kilo ohm as well as with voltmeter being connected. So on that case, this resistance, equivalent resistance or total resistance for these two branches across which we measure this V0. So that is the parallel combination. So R2 in parallel with this 100 kilo ohm. In this case it is 10 into, we can also make it like this, 10 into 100 divided by 10 plus 100. Like that also you can calculate if you have only two resistances. Okay, this is the parallel combination. So it is 1000 divided by 110. So this is equal to 100 divided by 11, that is equal to 9.09 kilo ohm. So now we assume that this becomes RT. So this combined effect of this R2 and this one, right, becomes RT value, that is equal to 9.09 kilo ohms. Now you can calculate this V0, that is 40, the supply voltage multiplied by the resistance RT. RT is 9.09 divided by the total resistances. So 20 plus 10, 30, 30 plus this 9.09, right? So that is equal to 363 point divided by 39.09. So that is equal to 9.30 volts. So this is for second case with voltmeter. So now we move on to case 3, in which this R2 value is considered to be 100 kilo ohms. It's 100 kilo ohms without voltmeter. The effect of this V0 is only based on this 100 kilo ohm resistance across which this is being developed. Okay, so this V0 is equal to Vs, that means 40 volts multiplied by resistance of this R2 divided by the total resistances. So 20 plus 10 plus 100, 4000 divided by 130, so it is 30.76 volts. So now go for this case 3 with the R2 value as 100 kilo ohms and with the voltmeter. So the voltmeter is being connected so that the resistance value changes across which we are going to measure this V0. So RT is the parallel combination of this R2 as well as this 100 kilo ohm resistance of this voltmeter model. Okay, this one. So R2 we have taken for the third case as 100. So 100 in parallel with 100. So you know that it is very well 50. There is no need to calculate, right? Because parallel combination will give you half the value. So this has the effect of this RT, right? Across which we measure the value of this V0. V0 is equal to now this Vs multiplied by this RT divided by Rs plus R1 plus RT. That is equal to 40 into 50 divided by 20 plus 10 plus that 50. So it is 40 into 50 divided by 80. So this V0 value is equal to 25 volts. Okay, now we summarize the answers. Okay, now we we'll summarize the answer now. So the case 1, that is R2 is equal to 1 kilo ohm with voltmeter, without voltmeter. We'll get the V0 value, right? So V0 is equal to 1.277 volts, whereas without 1.29 volts, not much difference. So the second case is R2 with 10 kilo ohms. So on that case, V0 is equal to 9.30, and this is 10 ohms. And for case 3, in which we considered this R2 as 100 kilo ohms, for that case V0 is equal to 25 volts, and here this V0 is equal to, that means without voltmeter, it is 30.76 volts. So as the resistance value increases, what happens? the voltage value actually increases, right? The difference increases. Okay. Okay, thank you. Hope you have hope you have understood and enjoyed the session. Thank you.